Hello class, today we're going to be doing is a review for the test on number bases or number systems. So what I'm going to do is these are the things I listed on the website, on Box, and I'm going to just go through all of them. So we're going to be converting any base to any base. There are three different ways to do this. So we have any base to base 10. What we need to do is we need to say, okay, we have a number 532 base 6. Now it doesn't matter what this base is. But what matters is this number creates these numbers over here. 1, 6, 36, and then we have 36 times 6, which is 216. So that's how we got those numbers. How we got them is 6 to the 0, 6 to the 1, 6 to the 2, and 6 to the 3. With these green numbers, we then take these numbers. So this 1 goes here, this 6 goes here, this 36 goes here. We multiply these up and we get three values. Then we add up those three values and we get the answer. So we have 2, 18, and 15, 180. So our answer is 200. Wow, I picked that number on the fly too. This is base 10. We don't have to put the base 10, but that's how to convert any number from any base into base 10. Take every value, multiply by the value of that position, then we would get a decimal value, and then add up those decimal values. The next way to do it is base 10 to any base. What we need to do is get the numbers, so let's go 543, and let's go to base 8. So we would need to do 1, 8, 64, and 512. We would go one above 512, but obviously 8 times 512 is going to be bigger than 543. So the first one we get is a 0, which you should figure out that number and write it down and then put the 0. The next one is does 512 go into 543? So we divide it. Yes, it does. How many times? 1. So we put a 1, multiply, do 512, subtract, and we get 31. So we're dividing 543 by 512, then subtract. Then we divide 31 by 64, we get a 0. We divide 31 by 8, we get a 3. It's 24. Subtract, we get 7, and we're left with 7. So our answer is actually these numbers starting here and going up. So we have 1, 0, 3, 7, base 8. And again, it doesn't matter what base we're going to. The only thing that changes are these blue numbers right here. Other than this number, and these blue numbers right here, and nothing changes depending on what base we're going to, as long as it's decimal to that base. Now comes the issue when we have a random base to a random base, not 10, for both of these, not base 10. So say we have base 6 to base 7. These are a pain. Why? It's two problems in one. So what that means is if we have 312 to base 7, it's 312 base 6 to base 7, what we have to do is we first have to convert this to base 10 and then take this base 10 number and convert it to base 7. So to do that, it's simple. 1, 6, 36, multiply it all out, we get 2, 6, and 6 times 2 is 18, plus 9 is 108. Add these all up, we get 106 base 10, and then we take 106 to convert to base 7. So we have 1, 7, 49, and then a really big number. So we go 98, subtract, we get 28, so 211. So this is 211 base 7, and that's how we convert any base to any base. This is the question everyone's going to get wrong because they're going to be completely confused because they're not going to remember this step right here. Even though they know how to do it up here, applying that information is going to be a trick. But you do know how to do this, and I did teach it. Just not this specific question, but I did put in here you need to know every base. I expect you to think outside the box. Understand 0 to 15 in base 16. What that means is you should be able to count. So let's count. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let's go 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, because 11 plus 16 is 27, 28, 29, 30, 31, and 32. I should change this to 20, but it doesn't matter. It's good enough, because if you know how to do that in base 16, you should be able to do it in the other ones. But again, technically up to 20, which would be 14. But I just went all the way just because. The next one, hopefully you guys can see me, probably not. The next one we're going to do is no octal, hex, binary, and decimal. So I'm going to cut this down right here. So we have octal is 8, hex is 6, binary is 2, hexadecimal is 16, and decimal is 10. These are just keywords that you need to know. Count in binary. So let's get out the trusty 1, 2, 3, 4, 5, 6, 7. Now I'm going to take this right here, and I'm just going to copy it. We know how to count to 7, so that means we can count to 7 with a 1 in front. I'm going to order this left justified, and now we just need to type in 1, 2, 3, 1, 2, 1, 1. And look at that. And do that on purpose, and let's even change the colors. Ooh, I'm getting all pretty. So that's only numbers we need to change to count from 1 to 7, and then we need to count all the way up to 20. So 16 is going to be 1, 0, 0, 0, 0. I'm going to take these numbers, copy them, move them over here, and then all I need to do is down here I need to count 16. I need to change these numbers from 1s to 0s, and then I need to take these, copy pasta, put it to 1s. So all I needed to really do was add in this column right here. I'll make it purple, and boom, I counted up from 16 to, this is 17, 18, 19, 20, 21, 22, and 23. So I gave you a little extra there. Again, just take the same pattern before and just add 1 to it. I should have put a 0 up here, technically, and then these two would have been up here. Any base 2 up till 16. I'm going to do this in Excel real quick. And we want to count all the way up to 20. So these are the bases. I'm going to skip to 2 because 1 is always going to be 1. So in base 2, 2 is, we already did binary, so now we need to do base 3. So this is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, because 9 plus 9, 201, 202, 20. And please note the time that this takes for me to do too, and hopefully I won't have to edit it, but we'll see. 4 would be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 16 plus 4. 5, again, every time you increase the base too, it's going to be easier to count because you're getting more and more closer to decimal. So we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. And again, notice how the numbers are getting smaller and smaller every time. So we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 6 times 2, 13, 14, 15, 16, 17, 18, 6 times 3, 19, 20. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Again, numbers are getting really small now because we're getting really close to decimal. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 9, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 10 is stupid easy. I'm not going to do that one. Sorry. 11, 2, 3, 4, 5, 6, 7, 8, 9, A. That's 10, 11, which is confusing. 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. I did those two extra just because they are important, and you should know them, but whatever. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And so now I'm going to do is copy pasta because it's always going to be the same up until this point. So C, D, E, F, G, H, I, J. Oh, I didn't even need to do this. Alright, but whatever. I might as well. I'm already here. Let's count all the way up to base 20. Into 20. I got 20/20 vision after I saw this lesson. Okay, so C is my 13. No, C is my 10, 11, 12. 13 would be 10. And then I just go up. 11, 12, 13, 14, 15, 16, 17. And now, if you noticed, once we hit these single digits, we're just decreasing by 1. So I can say equals this minus 1. Bring this up. Bring this over. Bring this up. Bring this up. Bring this up. Oh, how I love Excel. I missed this one. Shame on me. Boom, done. Counted all bases 20 up to value 20. So this is the base, this is the value. So the other thing we need to do is to know the base 16 to 8, 4 trick. Base 16, 8, 4. And then we also need 16, 8, 4 to here. 2 binary, and then from binary, which are two different things. So what we need to do here is, if it's base 16, we have for every digit that goes to 4 digits of values 1, 2, 4, 8. So my Y would then, base 8 value, call it Y, would then be 3 digits of these values. And any Z in base 4, which is any value 0, 1, 2, 3, would then be these 2 digits in binary. The next one from binary, we would say we have, so if I'm going this to base 16, what I have to do is take the last 4 digits, convert that into a number. So we have 1 plus 2 plus 8 is 11, which is B. The next 4 digits is 1 less, so that's A. The next 4 digits is 2. The next 4 digits, again, is B. Wow, I got really lucky on this one. The last one is just 1, because I fill in 3 zeros in my mind. Base 8, I'm looking at 3 digits. So this is just 4, 2, 1s. This is 3. These 3 is 4 plus 1 is 5. These 3 are 2. These 3 is 1. These 3 is 3. and the last 3 is 3 again. And again, we don't need those zeros because those are leading zeros. From base 4, let's start off with green. We take 2 digits, so 2, 3. Next 2 digits, 1, 0 is 2. Because again, we're just looking right here, 2 and 1. The next 2 are 2, 2, 2, 2, 2, 2. The next one is 0, 3. The next one is 2, with the next one is 1. That's how to convert a binary number to base 16, 8, then 4. And you can do it quite quickly, but make sure you start on the right because you need to make sure you have the correct amount of leading zeros on the left. Last but not least is convert one of these actually to the base 16 and 8 to binary. So let's do a value. So this is just random values that are just bashed on the keyboard. Please realize when we're working on this, we actually want to go work down, so I'm going to put it this way. And I'm also going to space these out. It doesn't matter which way we work from, so I'm just going to go left to right. I recommend right to left just because I want you to get in the habit for this way down here. But I'm left to right, usually just easier if you can understand it. So A, realize I write 8, 4, 2, 1. A is going to be 8 and 2, so I have 1, 0, 1, 0. D is going to be A is 10, B, C, D 13. So 8, 2, 8, 4, 1. So 1, 1, 0, 1. E, F, yep. 3 is going to be 0, 0, 1, 1. C is going to be 1 less than D, so that's 1, 1, 0, 0. F I just know is all 1s, and A we already repeated, 10, 10, 220. So now that's my binary number, so I have to put base 2. If you don't put that base 2, the whole thing's wrong. Next one, A, is just 421. So this 2 digit is 1, 0. I can put the leading 0 if I want to. I don't have to because leading zeros are just erased. 6 is 1, 1, 0. 0 is, make sure you put all 3 zeros. 7 is all 3 1s. And then the last one, 0, 0, 1, base 2. Last but not least, these are 2 1 digits. So we have 1, 1, 0, 1, 1, 0, 0, 0, 1, 1, 0, 1, 1, base 2. And that's it. Hope you have a good one. I will see you later.